Hi viewers, today we're going to see about linear equations. So linear meanings, the terms have only degree of 1, x to the power of 1, y to the power of 1. Here we're going to see linear equations in two variables. X, y are two variables, or y, z are two variables. So with this, we're going to solve exercise 3a. X plus y and y plus z equal to 3 other examples for linear equations. Question 1, solve each of the following system of equations graphically. So we need to do in the graph sheets. 2x plus 3y equal to 2. Let's assume this as an equation 1. X minus 2y equal to 8. Let's assume this as equation 2. So from equation 1, we can get the value of x as 2x equal to 2 minus 3y. So x equal to 2 minus 3y by 2. So the value of x is 2 minus 3y divided by 2. By substituting different values for y, we can get the value of x. Let's just do a random values. Y equal to 0. Then x is going to be 3 into 0. So 2 minus 0 by 2 is 1. When we take y as 2, it's going to be 2 minus 6. That's minus 4 by 2 minus 2. If we take y value as minus 2, then it becomes 2. 3 into 2 plus 6. So 2 plus 6, 8 by 2, 4. So with all these values, we can plot the graph. And from the equation 2, we can derive the same way for the different values of y. What will be the value of x? And all these together, we can plot in the same graph sheet. So equation 2 is x minus 2y equal to 8. So x equal to 8 plus 2y. So by substituting random values for y, we can get the respective value for x. Let's take the value of y as minus 1. So 8 minus 2, that's 6. If we take value of y as minus 2, then it becomes 8 minus 4. Remaining is 4. If we take value of y as minus 3, then x is 2. So all these points we can plot out in the same graph sheet. And we can look for the solution. Where does it meet? So if you see this, it meets at 4 comma minus 2. So we can plot all the points and see where does it make the solution. 4 comma minus 2. Next question, 3x plus 2y equal to 4. Let's have it as equation 1. 2x minus 3y equal to 7. Let's assume it as equation 2. So from equation 1, we can get the value of x as 4 minus 2y by 3. So by giving different values for y, we can get the value of x. And then we can plot it in the graph. If we assume the value of y as 2, then 4 minus 4 is 0. If you assume the value of y as minus 1, then it becomes 2 into 1 plus 2. So 6 by 3, 2. If you assume y as minus 4, it becomes 4 plus 8, 12 divided by 3. So the value of x is 4. Next we can take equation 2. From that 2x equal to 7 plus 3y. So value of x is going to be 7 plus 3y divided by 2. Again, by giving different values for y, we can get the value of x. And we can plot it in the same graph sheet along with the equation 1, whatever we derived for x, to look at the point where it makes the solution, where both lines intersect. So when the value of y is minus 3, then the value of x is minus 1. So it is making solution as 2 comma minus 1. That's a place where it intersect. Question 3 is also very similar. 2x plus 3y equal to 8, we assume it as equation 1, and x minus 2y plus 3, we assume it as equation 2. So from equation 1, we can get the value of x as 8 minus 3y divided by 2. So by giving different values for y, we can get the respective value of x. To plot the graph, let's assume the value of y as 0, then x is going to be 4. And we assume the value of y as 2, then it's going to be 1. 8 minus 6, so 2 by 2 is 1. If you assume the value of y as 4, then it's going to be minus 2. You can plot those points in the graph sheet. From equation 2, it's not always necessary to get the value of x. We can even get the value of y if needed. X equal to 2y minus 3. So by assigning different values for y, we get the value of respective x. When y is 0, x is going to be minus 3. When y is 1, x is going to be minus 1. When y is 2, x is 1. 4 minus 3 is 1. So we can again plot this and see where it meets. It meets at 1 comma 2. It intersects. Next question 4, very similar one. Take the 2x minus 5 plus 4 as equation 1, 2x plus y minus 8 as equation 2. From equation 1, we get the value of x as 5y minus 4 divided by 2. By assigning different values for y, we can get the respective value of x coordinates. So when y is 0, x is minus 2. When y is 2, x is 3, because 5 2s are 10 minus 4, 6 by 2, 3. When y is 4, 20 minus 4, 16, 16 divided by 2, 8 for x. Same way from equation 2, here we can get the value of y. y equal to 8 minus 2x. So by substituting different values of x, we can get the values of y. It is not necessary always to get the value of x. So when x is 1, y is 6. When x is 2, y is 4. When x is 3, y is 2. So we can plot the graph with all these coordinates x and y and see where it makes the solution 3, 2. Next question 5, same way. Take 3x plus 2y equal to 12 as equation 1. Assume 5x minus 2y as equation 2. So from equation 1, we can get the value of x. That's going to be 12 minus 2y divided by 3. So by assigning different values for y, we can get the values of respective values of x coordinate. So when y is 0, x is going to be 12 by 3, that's 4. When y is 3, 12 minus 6, so 6 by 3, 2. When y is 6, it's going to be 12 minus 12, 0. From equation 2, we get x as 4 plus 2y divided by 5. By giving different values for y, we can get the value of x. So when y is minus 2, x is going to be 0. When y is 3, so 2 3s are 6, 6 plus 4, 10, 10 divided by 5 is 2. When y is 8, 8 2s are 16 plus 4, 20 divided by 5 is 4. So now we can plot the graph and see where it makes the solution. Next we'll go to question 11, as all other questions are very similar pattern. Solve the equation graphically and find the vertices and area of the triangle formed by these lines. So question 11 is a bit different. 6 to 10 is very same as 1 to 5. It's in a very similar way. Here we need to find additionally the area of triangle and their vertices. So by assuming y as 0, we get the value of x as minus 3. When y is 2, value of x is minus 1. When y is 3, x is going to be 0. So from equation 2, we can write x as 4 minus 3y divided by 2. By giving different values for y, we can get the respective x. So when y is 0, x is going to be 2. When y is 2, x is going to be 3 2s are 6, so minus 1. When y is minus 2, it's going to be, x is going to be 5. So with all this, we can first plot the graph. So if you see here, it's just like a triangle and 3 vertices. And we need to find the area of the triangle. So the 3 vertices and base into height is what will give us the triangle. So the 3 endpoints are the points which make the triangle are called the vertices. And also we need to find you can even label them with some names. And you can make a dotted line, or for a better understanding, I've given you the base and height in orange lines. So area is equal to half into base into height. The base is 5 units, if you see here. And the height is 2 because y-axis is in 0.5 difference. So it's 2 square units. Then the area of the triangle is going to be 5 square units. Hope this is clear. We can label them as ABC and write the vertices points also. Next question, 16. 12 to 15 is very similar pattern. So 16, let's take first equation as 1 and second equation as 2. So from the two equations, we can get the value of x. Based on different values of y, we get the value of x. So x equal to 3y minus 6 divided by 2 from equation 1. Here again, after finding the solution, we have to find the area of the triangle. So for the different values of y, we get the value of x. When y is 0, x is going to be minus 3. When y is 2, x is going to be 0. When y is 4, 12 minus 6, 6 divided by 2, 3. From equation 2, we can write x as 18 minus 3y divided by 2. And by assigning different values for y, we get the respective x coordinates. So when y is 6, x is 0. 18 minus 18 is 0. When y is 4, x is going to be 6 by 2, 3. Then y is 2, it's going to be 12 by 2, so 6. With all this, we can plot the graph and find where it meets the solution, and also it forms a triangular pattern on the y-axis. 3 vertices. We can just show the base and height to calculate the area of the triangle. So we can just have a dotted line or thick lines as shown in the picture. So area of triangle equal to half into base into height. Here if you see the base, that's going to be 2, 3, 4 units, and the height is going to be 3 units. So that's 6 square units as the area of the triangle. The following questions are very similar. So let's get into question 26. Show graphically that each of the following equation is inconsistent. So here inconsistent means no solution. They are not going to meet or intersect at any common point. So let's assume x minus 2y equal to 6 as equation 1, 3x minus 6y equal to 0 as equation 2. So from equation 1, we write x as 6 plus 2y. By substituting different values of y, we can get the respective x values to plot the graph. When y is 0, x is going to be 6. When y is minus 1, x is going to be 6 minus 2, so 4. When y is minus 3, x is going to be 0 because 6 minus 6 is 0. From equation 2, if you see equation 2, it's divisible by 3. So it's going to be x minus 2y equal to 0, completely divisible by 3. So x minus 2y equal to 0. So x equal to 2 times y. By assigning different values for y, we get the respective values of x. When y is 0, x is also 0. When y is 1, x is 2 times, so 2 into 1. When y is 2, x is going to be 4. We can plot the graph and see, is it inconsistent? Yes, they're not making any solution. They're not intersecting. Both the lines are parallel to each other. Hope this is useful. Thank you.